backscatter over the horizon radar site, which the military declared obsolete at the end of the Cold War, and they quit construction on that facility. What in fact the record shows is that the technology wasn't obsolete because of the ending of the Cold War. It became obsolete because of the advancement of the technology. The old backscatter technology, when objects came close in from a distance, you couldn't distinguish what those objects were. It wasn't so versatile as to be able to be used close and at a distance. What this kind of technology, the new technology brought in the program, allows you to distinguish objects at a very, very far distance over the horizon, as well as within just a few kilometers of the site itself. And to be able to distinguish not only objects that are traditionally high up, but it will distinguish objects anywhere from the ionospheric levels, as I said, many miles above the Earth, all the way down to the Earth's surface. And this includes cruise missiles, making cruise missiles technology obsolete in terms of delivery technology for nuclear weapons. So in that specific application, what we have is a far superior and advanced technology. In addition to that capability, the same transmitter can also distinguish which of those objects, as we said previously, are actually carrying nuclear payloads. And this, again, is quite important. In addition, there's a third application of this particular use of the HAARP system. If you increase the power level even higher, you can create what are called bit errors in the computers, the onboard avionic computers controlling flight of those incoming objects, so as to cause the computers to fail and the objects to crash. At an even higher level of energy, you can create another effect where actually electronic components melt, causing the missiles to disable and crash. Those are just some of the applications based on the patents. All of those patent applications tie right back to Bernard Eastlund. If we go to the next slide, in terms of additional projects, this one is interesting. This is the idea of creating an artificial ionosphere mirror, which can be tilted. Now, this is similar to what we were just talking about in terms of over-the-horizon effect, except what we have in this case is something that can be tilted, a plasma layer that can be tilted like a hand mirror to reflect radio frequency energy as opposed to light energy, which is what a hand mirror would reflect. So that they can manipulate it. And what's interesting is the HAARP documents itself actually show this particular use in terms of one of the primary uses for this technology, in addition to a number of others that we'll discuss as the presentation goes on. When you look at sort of the multifaceted aspects of the ionospheric mirror, we can look at the next view graph, which shows the plasma mirror here being generated from the antenna array on the ground for use in communications, sending communication signals over the horizon and maintaining communications, for the use of over-the-horizon applications. In other words, a multiple number of uses using this ionospheric mirror. One of the other important factors when you consider energy being sent up to the ionosphere in terms of energy densities, you know, when we talked about energy densities, you can walk out into a warm, sunny day where you're feeling heat energy. And that heat energy you feel is just comfortable, perhaps warmth on your skin. But if you take that energy and focus it through, say, a 3-inch magnifying glass onto the skin, the sensation won't be comfort at all. In fact, in a few moments it'll be burning your skin. It's the same idea here. What you have in this technology is this focusing, concentration, capacity that really brings about a technology previously only dreamed of in military planning circles. If we go to the next slide and look at other application of technology in terms of what it's capable of doing, it becomes even more clear. What this application is probably one of the more interesting ones. When you look at a HAARP transmitter, and this is again graphically depicted out of the patent files themselves, you'll see in this case a HAARP-type transmitter irradiating energy, radio frequency energy, out into space to a reflector. In this case, in the patent, describes a mylar reflector, which then bounces the energy back to the Earth to another point on the planet. So what you have, essentially, is energy entering the system in the form of natural gas being burned, converted to electrical energy, transmitted in the form of radio frequency energy, and then as radio frequency energy bounced back to the Earth, reconfigured into electrical energy, and then put back into an energy grid, making electrical energy available on other parts of the planet where otherwise it may not be available. A couple of problems. if you look at this reflector and you think about what would happen if it tilted slightly one way or another, recognizing the large distance between the points, a very slight alteration on this end would move this beam maybe through your neighborhood, maybe not. The question is the risk factors of this kind of application are fairly high. More than that, from a military application, military perspective, this is useful in terms of getting energy into a battlefield environment or energy into an area where it might be needed. But commercially, the possibilities of this application are pretty great. In fact, what they say in the patent is by the year 2000, this will be economically feasible to experiment with. The problem, from our perspective on this particular application, is that it represents, again, a use of energy that may, in fact, cross a number of lines. In fact, when you look at the subtitle of our book is Advances in Tesla Technology, this is probably the place where most people think back on Nikola Tesla. And Nikola Tesla, for those that may not be aware, was the inventor of the AC generating and transmission system that we all currently enjoy for our basic power supplies in our homes and our businesses. What Tesla envisioned also was a way of transmitting electrical energy wirelessly. In fact, when you look at the early patents, Bernard Eastland, it was Nikola Tesla's ideas that stimulated that particular interest on Bernard's part, and Bernard saw the applications. In fact, when I first looked at the HAARP story, the way I ended up getting involved in the HAARP story was reading an obscure journal article in an Australian publication called Nexus, talking about HAARP. And it mentioned the first 3 patents of Bernard Eastland. What I did then is go to the library, pull those patents, review those patents, and they referenced a couple of New York Times articles, one from 1915 and one from 1940. What struck me as I read those was, who was doing this kind of work in 1950, 1940? And the first thing that jumped to mind was it's got to be Tesla. And when, in fact, I pulled those original patents, it talked about a new weapon system with huge potentials that would, in fact, even melt electric circuits on airplanes many, many miles away. And this is early, just after the turn of the century, and then moving into the beginnings of World War II in 1940. So that was sort of the creative impetus. But one of the other areas of his interest was, again, this power beaming idea. When we look at this particular patent, what's interesting is APTI, Arco Power Technologies, actually got to try this. They got to experiment with this in Canada and actually get a object at a very high elevation to utilizing no on-board fuel supply to utilize radio frequency energy in this way. What's also interesting is a project operating on the University of Alaska Fairbanks called SABRE is taking advantage of the same technologies, the idea of focused power beaming. In fact, the person responsible for that was referenced in the power beaming technologies patents mentioned earlier by us, and also the key people involved in that technology in the 60s are still involved in it today. The only difference is it's now operating out of University of Alaska Fairbanks, and the only other difference is the stumbling block of the 60s was they had no way